Predicting environmental impacts of coal seam gas developments on Australia's water resources relies on a thorough understanding of groundwater systems and water flows. The Surat Basin is the focus area of many environmental impact studies because coal seam gas is extracted from the Walloon coal measures that lie beneath the basin. One of these studies is on the geochemistry of groundwater in the Surat Basin.
Well, the project is about getting a baseline of the geochemistry and mainly of the age of the groundwater in the area of the coal seam gas production. There are several aims in this project. One of them is to characterize the age of the groundwater in the different aquifers. And during this field trip especially, we focus on the Hutton sandstone.
So I'm just preparing some chemistry and stable isotope analysis.
Age has a very different meaning for groundwater as compared to a human being, where the age is a unique number. This is because groundwater, as we take it as a sample from one bore, is actually a mixture of different recharge locations and different times that flow together in this one well.
So we do one unfiltered and one filtered and acidified.
Another aim of the project is to test a new method which is able to determine the speed of groundwater through an acquitard. We try to establish an understanding of the aquifer system that we have here. The aquifer system consists of several layers of acquitards and aquifers. The aquifers are where the farmers get their water from. Acquitards hinder the groundwater flow. During this field trip, our team collects groundwater samples in one specific aquifer, the Hutton sandstone, which is below the Walloon coal measures where the gas is produced. From the recharge area in the north of the Surat Basin down to the south, along the groundwater flow close to Roma. We try to see the increase of water age along these flow paths, and we want to have also one depth profile where we sample all the different aquifer layers in one spot to understand the aquifer system as a whole. The knowledge that we obtain now on groundwater age is important because it will help us to determine the impact of the coal seam gas production in the Walloon coal measures if we can compare that with future measurements. Well, the quartz helium work that we do is a very novel methodology. It tries to determine the helium concentration in pore water from the helium concentration in quartz, which is in equilibrium to this pore water. The idea behind is the aquifer system has many layers, like a layer cake, and some of them are very transmissive. So the water flows very good in them, that's the aquifers, and other layers, the water flows very slowly in them. That's what we call the acquitards. And these acquitards play the major role in the coal seam gas business because they hinder the groundwater of the aquifers to go to where the gas production takes place, because the gas production depressurizes these layers. But since the water flows so slowly in them, it's very hard to characterize them, and the quartz helium method is one way to characterize their transmissivity.